In this video, we complete the proof of what our authors call Theorem 65, the theorem that says constant multiples of convergent sequences converge. And I want to remind you that in the previous video, we proved the theorem for the cases when case 1 was c was equal to 0, and case 2 was c was bigger than 0. And in case 2, we did a lot of scratch work. In this video, we're going to look at case 3. So we now look at case 3, which is when c is less than 0. Now again, we're going to do scratch work first, but the scratch work this time is we're going to mark up our formal proof of case 2 and see if we can modify it. So here's the proof of case 2. And this is now going to be, and I'm going to be marking this up in a different color. So this is going to be our scratch work for case 3. And in case 3, we're going to be changing this to c is less than 0. We're still going to look at s is going to be an open interval containing cx. We're still going to let delta be bigger than 0, and we still want this particular interval. But this gets changed to c is less than 0, and that means delta over c is no longer positive. Delta over c is negative, so minus delta over c will be positive. And that means I'm going to have to look at the delta ball centered at x of radius minus delta over c, because minus delta over c is going to be the positive number. Well, then let's see, continuing on, we get this open interval containing x. The sequence of pk still goes to x. So we still have a tail that is trapping the, we still have a tail trapped inside the delta ball centered at x, but this time the radius will be minus delta over c. And so this is going to be the delta ball minus delta over c. And that changes the end points of this interval. This will now be x minus delta over c, which is x plus delta over c. And this point will be x plus minus delta over c, which of course is x minus delta over c. So this inequality now is going to have x plus delta over c is less than Pn, and Pn will be less than x minus delta over c. And c is less than 0, so when we multiply our inequality, in addition to cleaning up the plus and minus signs on those two things, the inequality also is now going to switch. So that less than is going to become a greater than, and this less than is going to become a greater than. And what happens then is that I can then turn this inequality around to get that one. And so I will still have as my final conclusion that as long as n is bigger than or equal to capital N, the Cn term will be in the appropriate ball. And that means we will indeed get the entail of the CPK sequence inside the appropriate ball. To write this up formally, all we have to do is put these editing changes into the English. And I'm going to leave that as a task for you to do on your own to clean this up.